This is the presentation of group number 4 on a hydrogen production in Ecuador. We will address 6 important points on this topic. I will present the problem versus the solution. Strong reforming plants to produce hydrogen have numerous advantages over other processes. However, they produce high emission of carbon dioxide, which is very negative for the environment. Our group have the potential to compete with new technology, taking care that you as a company have the greatest possible benefits. But how will make this possible? We will do with a member separating system or also called absorption desorption. In addition, recycling is implemented with the absorbent gases, which become part of the tail gases. These gases are recycled to the burner so that the greatest amount of the product is used, generating benefits for the factory.
Hydrogen is considered the most efficient, non-polluting, abundant, and profitable source of energy for the immediate future. The production of hydrogen gas can be obtained from raw materials such as natural gas, ammonia, biomass, and others. The most used technology for the production of hydrogen is extend reforming using light hydrocarbons as raw materials. Generally, the use of paraffinic materials such as natural gas, which contain methane, is required to about the conversion of more pollution materials. In Ecuador, large amounts of methane are produced daily in different industry sectors. Reforming is a high-efficient product based on the conversion of hydrocarbons to simultaneous produce iron, carbon dioxide, and carbon monoxide. It's a clean fuel because the chemical energy stored the H8 for bone is released when it combines with oxygen in the air, producing only water as a product.
We note that steam reforming to produce hydrogen has several advantages over other processes that use hydrocarbons or other raw materials. It's a renowned method in the industry, and it has been commercial for a long time, demonstrating its effectiveness. On the other hand, this process doesn't require oxygen, and its operating temperature is lower than in the others that use hydrocarbon fuels. Produce reforming with a hydrogen carbon monoxide ratio of 3:1, which is considered high. And its efficiency is higher than a node hydrogen production technology, proving to the best alternative.
The process starts with natural gas and water. The natural gas goes through a desulfurizer and then to the nickel catalytic bed reformer where the reaction of methane and water takes place, forming carbon monoxide and hydrogen. The off gas is directed to the CO shift unit where carbon monoxide reacts with water to produce carbon dioxide and hydrogen, producing CO emissions. The heat released is used to preheat the natural gas as it enters the reformer. The gas produced is rich in hydrogen and passes through a condenser where water vapor is removed and then to a PSA system that works at high pressures on zeolite and obtain hydrogen with a purity of 99.999%. Gases other than hydrogen are absorbed and constitute the tail gas, which are also fuel and are recirculated to the reformer burners. Estimate costs were based on Ecuador rates. Natural gas costs $2 per million BTUs. Energy costs $7.91 per kilowatt hour. Water costs 72 cents per cubic meter. Maintenance and refurbishment costs are 3% of the capital invested per year, and the labor rate is $40,000 per year.
For the process to be efficient and to guarantee a methane conversion of around 92%, the following operating conditions must be met. The process will be strongly endothermic. The catalyst to be used will be nickel, which is less expensive and increase the conversion of the process by 5%. The reformer must work at a temperature of 1200 Kelvin and a pressure of between 20 and 30 bars. Theoretically, the correct thing to do is to use a water requirement equivalent to a stoichiometry, but we will use an exit at a rate of 2.5 to 5 mol of H2O per CH4 to avoid the formation of carbon on the nickel. This is very important since if this scenario is now avoided, the heat transfer is reduced along with the productive capacity of the system.
Next, we will meet other factors who are involved in our proposal. First, the conservation of all product of interest, which is hydrogen gas, taking into consideration that in the most processes the use of hydrogen in the gaseous state is required. It is necessary to stir in a high pressure. For this stir type, it is required that the tanks meet two characteristics. They should be heavy and bulky. In addition, it is necessary for the safety in the processes of storage, distribution, and loading of hydrogen. However, hydrogen can be stored in a liquid state using a cryogenic container. This vessel needs to resist very low storage temperature. Second, the various applications that hydrogen has at an industrial level. Hydrogen is used in various industrial processes. However, the main utility is in the chemical industry, in hydrogenation processes or as reducing agent. It is also used as aerosol fuel, water treatment, and as liquid coolant. Finally, there is currently a new application that is fuel cells, which involve an energy alternative, generating an overview of hydrogen economy. In this factor, the production of green hydrogen is projected as a way to eliminate the energy need of society, since hydrogen can be generated from renewable sources.
Viability in Ecuador is the 88% of hydrogen come from oil. The main process of obtaining is the reforming. The conversion yield in the water vapor reforming process is 83%. Ecuador in 2020 produced more than 1 million of barrels of naphtha and more than 1,000 barrels of GLP. Ecuador produced between 50 to 1,000 million cubic feet per day of natural gas. Okay, the members of this group are Estefania Cabrera to do the problem statement and solution, Nayesca Cañarte make the introduction, Rosa Chaguay the advantage, Romina Tapia the operation and condition, Christopher Gomez the process operation, Suani Salcedo the factor involved, and me, Giovanna Gomez, viability in Ecuador. This is the bibliography. Thank you.